for Europe. Welcome to this Escan Academy webinar. This is our 24th of our series. As Fernando said, my name is Jose Pablo Chavez. I am currently Deputy Director of the Institute of Research in Technology from Comillas University. I'm glad to have you on today's webinar. I just as a reminder, you can have this webinar and the previous one in our webpage, the Escan Academy, as you have it in the link below. And this webinar will be recorded and sent it to you early next week. So what is Escan, just very quickly, is a joint initiative of the International Energy Agency and the Clean Energy Ministerial, and is the only strategic platform to support high-level government knowledge transfer and action to accelerate and the deployment and development of smart, cleaner electricity grids around the world. We are organized in 8 different annexes, as you can see in this slide. From case studies, cost-benefit analysis, synthesis on insights for decision makers, a smart grid international research facility network, power transmission and distribution systems, smart grid transitions, and Annex 8 is the Escan Academy. So we are in 26 countries, as shown in this map, including as well the European Commission. And what we do is to have strategic partnerships. What we do with conferences, policy briefs, technology briefs, technical papers, discussion papers, webinars such as this one, case books and workshops. And we do all this in collaboration with, as I said, the strategic partnership with the International Energy Agency, with the Clean Energy Ministerial, with the Global Smart Grid Forum, Mission Innovation. Also, we have a broad international expert network which help us to keep a good quality of our research and our outcomes. Global and regional and national support for policymakers, and one of our main purposes is knowledge sharing, technical assistance, and project coordination. You can visit our website where you can have open access material on all these different work that we do in Escan. As for today's webinar, just let me briefly introduce. We are presenting today 3 different projects that are Horizon 2020 projects. One is focusing FlexPlan on long-term planning challenges for transmission and distribution planning. Another one is the CoordiNet project, which is focusing on coordination at the operational level and transmission and distribution that I will present later. And this is a series. CoordiNet is following up the work that has been done with SmartNet. And also we have a twin project that is looking at similar topics called Interface, which is going to be presented next week. And finally, the Interpreter project, which is focusing also on flexibility, more local flexibility, that will be presented briefly now. So thank you, everyone, and thank you the rest of the presenters for being available for today's webinar.
Okay, thank you, Jose, very much. Hello, everyone. My name is Nuno Amaro. I'm a senior researcher at RD&I in Portugal. And before going into the context, into a short context description and into the projects, I think it's also important for us today to present a bit the Bridge initiative. Just a very general overview for those who might not know it. Bridge, it's a cooperation group from H2020 projects, and aims to foster the continuous knowledge sharing among the different projects, working into different working groups. So Bridge organizing into different working groups, allowing to have different projects to showcase their results and to cooperate together. In fact, we are organizing through Interpreter project a series of 2 webinars. So this one and one organized next week. And these two webinars are a collaboration action of 5 H2020 projects, which are somehow either directly or indirectly related to Bridge. Okay, so now just for a very quick context for power systems and why flexibility is needed. So we all know that we are in a very quickly changing context in power systems. There are mainly 3 different goals from the European Union energy policy, which aims to have a secure, resilient and reliable supply of energy, also to have an affordable and market-based energy services, and of course to reach these technical solutions with the reduction of pollution and with the protection of our environment. So basically this is based on the energy trilemma presented from the European Commission, so the environmental sustainability, energy security and affordability for the solutions. So in fact, why do we need flexibility? Well, as I said, mainly we are in a very quickly changing context, and we need to aim for carbonization of power systems. At the same time, we are facing a decentralization of generation. So with the steep increase of PV mainly, but also small wind farms, we are facing a decentralization. And of course, this changes quite abruptly the context of the power systems when compared to some decades ago. And similarly, so we are going through a demand disruption. So customers are now being started to look as the main active or even as the center of the power system. And of course, all of this is only possible due to an ongoing digitalization of the system as a whole as well. So flexibility is basically needed to move from the past, from the historical one direction flow of energy to the already existing and future power system context in which we have multiple flows coming in both ways from many different activities, as we are having more and more active consumers and the massification of usage of electric vehicles and storage and other technologies as well. So of course, if we need flexibility, we need to have flexibility enabled. So we need to provide solutions that allow us to have this flexibility, both from the system level and from the technological level. And these flexibility are, there is the clear need for these solutions and for these enablers. And this is identified at multiple sources, as we saw in the last slide. So ETIPSnet have this clear identification or this clear need. Also, even at the operational level, so as one example, ENSOE is now using or is now identifying power systems flexibility as one of the main clusters that we should look into in RD&I projects. So basically, of course, there is not one single solution for flexibility. There are many different flexibility solutions, and some of those are being leveraged by RD&I projects, in which H2020 plays a major role. And these projects are not, let's say, purely research. They, in fact, they involve grid operators, regulatory bodies, technology providers. So all the industry is involved in this, in the development of flexibility and the related solutions. And now moving a bit to one of the projects, the first project, let's say the project in which we organize these webinars. So Interpreter aims to be part of the solution in terms of flexibility. Just a very quick overview. So Interpreter aims to provide a modular approach for the creation of different interoperable tools for grid operation and grid planning. It's a research and innovation action funded by the European Commission, by the Horizon 2020. And the coordinator is Circe. There is a total of 9 partners, as you can see in the different figures. The overall objective of Interpreter is to develop a modular grid management solution. So this set of interoperable tools we will check them later. These tools can be either offline or online, meaning that some are based on online data, on historical data, but some are based on real-time data coming from the power systems. There is a special focus on distribution grids, although these tools can be, some of the tools can be also applied to transmission systems. And the tools will be offered to the grid operators through an open source software platform. The solutions are being validated with 2 DSOs. There are 2 DSOs in the consortiums, and of course, partners from these 6 different European countries, which provide a representative set of use cases for ensuring the replicability and also the uptake of the interpreter solutions across different countries in Europe. So a very quick overview over the interpreter architecture. So basically we have a core platform which is based on Fuse platform from Atos in Spain. And the idea is that we have an API service running on top of a semantic repository and, let's say, a data lake to offer services to the different tools that the project it's creating. Of course, the platform is also connected through different adapters to the pilots that will be providing the data to validate the services that we are creating in the project. So we have a pilot through also in Ores, another one in Cuerva, so two DSOs, and then a third pilot which is related to the usage of data coming from the DTU University, the Danish university. And finally, in terms of services to be provided, so what will we develop in interpreter, and how are these related to flexibility? So we develop grid operation and maintenance services, and also grid planning. And there is one service which would be common to both, which is the low voltage grid modeling tool. So we will create a tool that allows to model the low voltage grid networks based on statistics and on information coming from the actual grid. So we contribute to flexibility related solutions at both levels, grid planning and operation. So if we look into operation, we are mainly focusing on grid control optimization, self-healing strategies, also on the provision of ancillary services for DSOs or at the DSO-TSO interface level. And of course, looking into the grid planning, these flexibility solutions are related to technologies as the optimization of the storage location and size, so an optimal location and size algorithm for storage. Also the definition of the capacity that grid nodes have to receive new generation units, and reactive power compensation, so among all the other different solutions. So this was a very quick overview over interpreter and what are the solutions provided and how are they related to flexibility. So I would now pass the word to Gianluigi, to the next presenter. Thank you.
Okay, thank you, Nuno. I will start again from giving the context, because I want to highlight a couple of things that will then be important for the FlexPlan project that I'm going to introduce. So first of all, the energy transition that we are now in the middle of, and that is also driven by the ambitious targets from the European Commission on decarbonization and energy efficiency, is bringing to a massive RES deployment, the commissioning of conventional power plants, the development of a lot of distributed energy sources in distribution that is becoming an active grid. And as Nuno was already saying in his slides, an empowerment of the customer that becomes the center of the system, and that brings with itself the development of smart grids and local communities. Consequences of this kind of important Copernican change of the system is a more attention to ancillary services that, of course, include not only traditional services, but also innovative ones like artificial inertia and fast frequency services. the need of TSO coordination that has to be brought in the framework of the real-time markets, and the development of those markets as well that are coupled in Europe in the future years and also extended to distribution grids. And all that has to do with the adaptation of algorithms for control of the system and for the markets to a situation in which the quota of renewables will become very approximately 100%. That is something very new, and that needs to put in place special attention and mechanisms. The development of retail markets and capacity markets, and last but not least, especially for FlexPlan, the need to reform the grid planning procedures in order to cope with variable flows due to renewables. That is, of course, a regulatory process that has to be coordinated with the European Commission and with the national regulatory authorities in order to foster the bad fitting pattern and avoid unharmonized developments in Europe. So, okay. I want just to remember two projects I've been and I'm coordinator of. The former is SmartNet that compares 5 different TSO-DSO operative interaction schemes and different real-time market architectures in order to find which is the most efficient one, so the one that realizes the best compromise between cost and benefits. And that has to do with market and operation. That was a project that lasted 3 years, Horizon 2020, and finished in June 2019. And in October 2019, I was again coordinator of that new project, FlexPlan, that is oriented to study new grid planning methodologies that are able to consider flexibility and storage as part of the planning procedure itself, so as an alternative to build new grid elements. What is the motivation of the project? So, of course, the high-speed deployment of RES is making transmission and distribution planning more and more complex and affected by uncertainty. The investments, which are capital intensive, need even a decade to be realized for the most complex ones in transmission. And when a new line is commissioned, it could be already not any longer be completely included or coherent with the current scenario, because RES are changing in their plans and deployments very rapidly, and so could be regarded already as a stranded cost with a big waste of money for the public, for the states. And so building new lines it is meeting more and more hostility from public opinion. That makes planning activities even longer and affected by uncertainty. And we have to take into account a new type of intermittent congestion that is generated by RES that sometimes is so short in duration that is better compensated by flexibility than with new lines whose investment cost would not be completely justified. And if we put this together with the view of a virtual power plant that is something that puts together storage or flexibility with the RES generation in order to produce something that can be plugged into the system in a more reliable way, so more dispatchable way, as one can say. So hence we get the idea of establishing a new grid planning methodology that considers the opportunity to introduce storage and flexibility resources in transmission and distribution grids as an alternative to build new grid elements. So the consortium for FlexPlan is not very wide because it's a 4.5 million project, but in any case, all the partners are very selected. So we get many of the most important research organizations in Europe. And I put in this list also inside that he developed the Euphemia platform for the market coupling in Europe. We have 3 transmission system operators, one on Italy, of Portugal, and of Slovenia. And we have Enel, that is one of the most important DSO concerns in Europe. And we have, of course, among the research partners, RSC and myself, I'm the coordinator of this project. So the center of this project is the creation of a new planning tool that is able, given a basket of grid candidates, grid and flexibility / storage candidate, to provide an optimal selection of them in order to minimize the sum of OPEX, so operative cost for the system, and the CAPEX, so the investment cost for the infrastructure. Also take into account security impact and environmental impact. We want to do it for 2030, 40, and 50 at the same time. So, of course, in input to this tool, we need also generation and demand time series. And also we need transmission and distribution grid data in input based on the T1DP by ENTSO-E. All that being said, of course, we have decision variables that are I invest or I don't invest in each member of this basket of candidates. And so what we do is creating a best planning strategy selection tool that considers a limited number of expansion options. And from the mathematical point of view, that makes up a mixed integer program with sequential OPF. We consider altogether transmission and distribution integrated planning, and we also consider environmental analysis in air quality, carbon footprint, and landscape constraints. We consider altogether 2030, 40, and 50, and we consider in the framework of a Monte Carlo process different combinations of rest time series and load time series during 1 year that of the 3 grid years that we consider, so 2030, 40, and 50. We also consider all the criteria that we are including in the cost-benefit analysis, also part of the target function. So there is no difference between the CBA and the target function, what it contains. And we replace N-1 security criterion with probabilistic elements that come from a project that studied this kind of issues in detail, that is the Garpur project. And finally, we, as what results is a huge problem with a huge number of variables, we study also the possibility to introduce ad hoc decomposition techniques in order to reduce calculation efforts. So in principle, we have a formula that is the target function for the project that considers operational cost for existing generation and load, considers operational cost for new investments, where alpha are the decision variables that are integer variables. It considers contingency costs as the product of the curtailed load delta P times the vol for the system, for each kind of quantity in the system, and all of that weighed with the probability of each kind of contingency that we are going to use and consider. Then we are going to consider also investment costs. So alpha is again the decision variable multiplied by I, that is the investment cost. So we are also modeling environmental factors, as I said. First of all, landscape impact modeling that says that the cost of a line between A and B in the basket of candidates is found out by considering the minimum cost path between the 2 points within a network, a graph of possible paths that takes into account in the way that is the cost between 2 points, all factors that have to do with landscape, that is whether it is on the mountain or in the flatland, if there is a densely populated area, or and so on. Then we have a second point that is air quality. It is air quality. Okay, and the model for air quality consider the whole chain between emissions and cost by passing through air concentrations and impacts on health. And in particular, it's particularly delicate because it's originally not non-linear, the passage between emissions and air concentrations. And we are using for that parameters that are taken from huge meteor models that we run in order to tune those small parameters that we use in order to pass from emissions to air concentration. So this model is matching big models in order to take the parameters with the planning tool that is using those parameters in the linear scale. Finally, we have also carbon footprint that is of course a model of the full chain between when an infrastructure is created to its disposal. And for each infrastructure in the basket of candidates, we consider the full range of costs, of course, including the cost that is cost due to emissions that are created if it is a generator, a conventional generator, but not only. We consider also the CO2 that is created when this infrastructure is created and what is spent when it is disposed. So, okay, here is an example of the decomposition algorithm for the 3 grid years. So instead of having all the integer variables for the 3 years, we decompose in 3 steps. In the first step, we retain the integer variables only for the first grid year, that is 2030, and we relax the integer variables in continuous variables in the interval between 0 and 1 for 2040 and 2050. Then we retain the integer variables that were selected in the first run of the planning tool in this way. And we put the integer variables on the second grid year and we relax them for the third grid year. And we run again the planning tool, and then for the third step, we fix integers for 2030 and 2040, and we have integer variables only for 2050. This technique that is called fix and relax is taken from other kinds of applications, and it is applied in this kind of planning problems for the first time. So we have to test it, of course. Then, of course, I've said till now that we need a basket of candidates that the planning tool is going to analyze. Those basket of candidates is created by a preprocessor that is analyzing a non-expanded OPF and takes from it the Lagrange multipliers that give information on how is the improvement of the target function for a relaxation of a unit relaxation of the constraint. And so we use it in order to see what are the lines that are more promising for refurbishment, so for expansion. But we use also LMPs, nodal LMPs, in order to see where storage and flexibility could be located. Of course, as a non-expanded OPF can initially be only created for 2030, also here we need an iterative process in which we start by running the non-expanded OPF for 2030, then we run the preprocessor at 2030, the planning tool that at the end takes out investment for 2040. So we can create non-expanded OPF for 2040, run the preprocessor at 2040, rerun the planning tool and take investments, possible investments for 2050, and so take non-expanded 2050 OPF and make for the last time the chain in order to run the last time the planning tool with a distinct set of candidates for 2030, 40, and 50. About scenarios, we are making a 4 steps approach in which first we prepare the grid mold by setting the grid, so the nodes in the system. Then we perform the so-called regionalization, which we match rest capacity and loads to the single nodes. Then we run a market simulation for cross-border exchanges that is used in order to set homogeneous border conditions for 6 regional cases that serve not only to validate the planning tool for several cases, so 6 cases that span all over Europe, but also to provide at the end an image of what could be the role in the planning for storage and flexibility from the mid-term, so 2030 up to 2050, so the long term. About the source of data, we adopt ENSO-E scenarios. So the three scenarios: national trends, distributed energy, and global ambition. For 2050, we have to extend scenarios because the TUNDP by ENSO-E doesn't provide 2050 numbers. And as we extend it to 2050, we use the document A Clean Planet for All by the European Commission for the validation. Then we use the transmission grid model by ENSO-E for transmission, especially for extra high voltage, and OpenStreetMap data in order to set sub-transmission data, because we need big details, so nodal details for it. And then we, for distribution, we elaborate synthetic distribution networks by using a tool that we have in RSC that is based on network statistics, but also with the help of the GRC tool Dynamo. Finally, a conclusion. So what we are going to provide at the end of this project is not only a set of tools and the methodology, but we want to provide, as I said, a view for national regulatory authorities and the European Commission of what would be the role for flexibility and storage up to 2050. And so depending on that, we conclude our project with some regulatory guidelines in order to see how this process could take place, because you know very well that as the grid operators are not allowed, if not in special case, to own storage. And so in case their planning tools will elaborate that storage is opportune, it is up to the national regulatory authorities to provide incentivization programs to investors and then in real time for aggregators in order to incentivize them to provide the opportune bidding strategies in order to materialize the benefits that were foreseen by the TSO and DSO. So by concluding, FlexPlan is going to provide system operators with a tool to allow optimal contribution for storage and flexibility to grid planning, but also national regulatory authorities with the regulatory guidelines for optimal exploitation of storage and flexibility in planning. Thank you. Of course, we have a website that we encourage you to see.
Okay, thank you, Gianluigi. So last but not least, I'm going to update a bit on the CoordiNet project. This is a TSO-DSO customer demonstration project on innovation network services through demand response, storage, and small-scale distributed generation, which are providing services to both, again, the challenges, both TSOs and DSOs, and to elaborate on previous projects, as I mentioned before, and go further on this. As you can see, there are these are the countries where there are partners, but basically there are 3 demo countries: Spain, Sweden, and Greece. This is a project that started in January 2019 and will end on June 2022. The total budget of the project is 19.2 million euros. So it's quite a large project with contribution from the European Commission of 15.1 million euros. We are in total 23 parties plus 10 linked third parties. So what's the objective of the project is to demonstrate the activation and procurement through a TSO-DSO coordination, procurement of flexibility services, define and test standard products to provide services to the network operators. We are in the process of making the evaluation and the demo runs of these products that has been defined, and to develop a TSO-DSO customer collaboration platform in demonstration areas to pave a way to an interoperable development on a pan-European market. So these are the partners that are involved. So we are counting of big research centers, universities, TSOs, DSOs are part of the project. So we make this real collaboration. Part of the results of this project are going to be implemented in real life. already there are local markets that are functioning in the case of in Sweden, new markets that are in the process to be created and to enlarge the participation of new assets as in Spain, and as well in preparing for the future and in Greece. And we have also the DSO, EDSO, the Association of Distribution System Operators, one of them in Europe, technological providers, flexibility providers, and aggregators. Also, we have city halls in Malaga, in Spain, and Uppsala in Sweden, and also different solution providers, Spectra, Engineer, and Site as well, which are providing platforms for the procurement of flexibility services. So what is the approach of the project? We have started identifying with the identification of the most valuable coordination schemes to advance what has been proposed until now, and see to what extent they adapt to different environments. We have defined different grid services. Some of them are already defined. In the case of balancing, these are very mature services that has been in the process of harmonization in Europe. But in case of other services, congestion management, voltage control, there is still room to and still development on defining specifically the service and the attributes of these services. We are looking at the time frame mainly at the day ahead and intraday. However, there is one in the demo longer term time frame, but it's mainly focused on the activation of these services and different kind of customers that are providing these services. So we have a list of standardized products as seen here that has been defined and implemented. And the idea is to have this collaboration and coordination between TSOs and DSOs to have a common platforms to acquire flexibility services, to manage data, algorithms for market clearing, and to allow both demand and generation forecasting. Once the needs has been identified, so the bids are sent to the flexibility providers, and the needs, then the providers send the bids, and then once it's clear in the market, the activation take place. So these are the different services: balancing, congestion management, control line landing, and voltage control that we are considering in the different demos. And on top, you can see the time frame. So as I said, it's mainly on day ahead, intraday, and real-time activation, but we have long-term procurement in the case in Sweden. The market model that we have defined, I will explain more in detail what are these market models that we have defined in CoordiNet, and based on the existing proposals, and if the product is more capacity based or energy based. On your right, you can see the different on top different kind of assets that we are considering. So small renewable assets, large generators, aggregators, customers, consumers, storage, and other flexibility providers, such as backup generators, for instance, that they are all in a level playing field, providing these services to the TSOs and DSOs. So as you can see, in yellow, those demos that takes place in Sweden, in the magenta, you can see almost red, those in Spain. So you can see in here the different demo areas in Murcia, Albacete, Malaga, and Cadiz, where, but for instance, balancing is going to be tested using a central approach and mainly focusing on energy. So you can see in this slide all the different demo areas and all the different market mechanisms, time frames, and product type that we are currently testing in the project. So with respect to the coordination scheme, so we made these questions ourselves to kind of present and to derive different coordination schemes. So the first one is, where is the location, the need, when it's located in the power system. So the need can be central, In case, for instance, of balancing, as balancing is a single need for the whole system, or it can be central and local. In case of congestion management, you can have a congestion that is local but also central, or you can have a need that is more local. In the case, for instance, of islanding in a specific area. So who is the next question is who is the primary buyer of the flexibility? Here we have different options. It could be the TSO alone, the TSO and the DSO, both, and external stakeholders. That means, for instance, balance responsible party that wants to reduce energy imbalances, or it can be peers, so just trading energy among the market parties or the DSO. Then the next question is how many markets has been utilized and used this flexibility. We can have a single market, or we can have more than one market. And next is how does the TSO has access to the assets in distribution. So you can see that in some cases there is no direct access. So the access is done through the DSO, or the TSO can have direct access to the resources. So finally, that results on different market models, as you can see here: a central market model, a common one where the TSO and DSO can access together, a multi-level in case there are two markets that both two markets where both TSOs and DSO can have access. In case only the DSO can have access, we are calling this the fragmented market model. Then you have the integrated market model, where not only the TSO and DSO are buyers, but also external stakeholders. The distributed coordinate market model, where only peers-to-peers trade, and then the DSOs and TSO just set the boundaries for that trading. And the local market, where is only the DSO locally with little interaction and effect on the TSO. So based on all these defined market conditions, as we are currently working, so the project is in different phases. We are currently in phase 2. Phase 1, we have a look at regulation, the needs of the TSO and DSOs, what are the capabilities of the DERs, the business use cases, and KPI definitions. We are currently running in the first demo run in Sweden. Has done already. We are in Spain and Greece starting with the demo runs. Then the next step, the next phase will be on collecting the results from the 3 different demos, and the final phase will focus on results here, conclusions on improved customer engagement, guidelines for the integrated market platform, potential replicability and scalability analysis, technical, social, and economical regulatory aspects at the end to provide some regulatory recommendations. So what is the platform? This was explained before, the platform concept. For making that first TSO, DSO, we need to have monitoring and the operation of the platform. To make the match, there is a need for the market operation, and to manage the DERs and the flexibility providers, we need to have tools for managing the aggregation of resources and disaggregation to send the activation signals. Then we are building different interfaces among them to allow the activation and to compute the needs, and also to send the bits and the activation signals. Finally, we need input-output data needs and a standard for interoperable platforms that can help these interfaces. So in the first step, we are working on different aspects of grid monitoring and operation for load forecasting, real-time monitoring, renewable forecasting, state estimation, system operation, and metering. Then for this, we once the needs are identified, they are sent to the common platform, and the needs then are sent from the flexibility service providers, where they do also these different activities such as load forecasting, renewable forecasting, flexibility estimation to create the bids and at the end dispatch. Once the bids are submitted, then it comes the market operation where the bids are processed, the market clearing takes place, and the results are communicated. At the end, we get from the system operators and also from the aggregators and flexibility providers the market results and the activation and real-time status. So you can see here, at least in the European context, we are talking about the regulated aspects. So the network operations and system operation, which is regulated activities, and non-regulated in competition. So the flexibility providers are in the market environment. We will have standard interfaces for making this possible, and interfaces that sometimes are not standardized because we need to make it possible currently this operation among the different players. So finally, we will get this once the flexibility providers submit the bids and make this communication. It could be the case that there is a limit in the DSO which cannot affect the delivery of a service to the TSO. So that is going to be managed through this market platform. This is kind of a long-term view, but we need to get the implementation of the platforms today. So the idea, in some cases, we have made some steps to have this long-term view of all these different aspects. The demo sometimes will not, they are restricted, so maybe not all these activities will be possible to implement, but most of them are in different phases, and also depending, as I said, in the case of Sweden, is already a market functioning. New markets in Spain, we have enlarging and creating new markets, getting the first steps that it's not only a research project, but also go to the market reality. So thank you very much. I am the communication and dissemination leader. My name is, as I introduced at the beginning, Jose Pablo Chavez. The coordinator is Marco Barón from Enel. And you can visit our webpage where you can find all the details on the demos and the platform developments that I have explained till now. So thank you very much from all the, well, not only from Nuno, but I think from all the presenters. And please, now it's time for questions.